UDC.
Esri's ArcGIS Pro Utility Network extension includes an array of functionality out of the box that enables GIS users to intuitively build workflows that previously may have required one or more custom-built applications. In this video, UDC's senior consultant, Angela Reising, demonstrates several GIS workflows in Utility Network for modeling a cathodic protection subnetwork in your GIS. Watch as she walks us through tracing and symbology, adding a CP facility to create a new subnetwork, and regenerating subnetworks within the utility network.
While many companies previously had extensions or custom tools for tracing networks such as cathodic protection areas, Utility Network provides enhanced functionality to do this out of the box. Within system, pressure, isolation, and cathodic protection tiers, the subnetworks contain connected features which share common sources or sinks referred to as controllers. Let's take a look at how we can trace and update these cathodic protection subnetworks. We're working in Esri's sample Naperville dataset. We are also going to be using tasks as we walk through this demo. Tasks can be configured to store a set of pre-configured steps to guide users through workflows. Actions can be assigned to the steps to automatically open tools as you click through the workflow. First, we'll run a trace based on an existing cathodic protection subnetwork. This should have the same results as what is shown in other CP systems if the data is aligned. As everyone manages data differently, as we walk through these steps, think about how you manage your data and if there are any gaps that should be considered before implementing UN subnetworks. First, on the Utility Network Data tab, we're going to click on Subnetworks in our Tools box. This will open a geoprocessing tool, and we're going to populate some of these boxes. You'll notice that some of the boxes are pre-populated, and as we go, every box below is pre-populated with a pick list based on what we select. We'll select our pipeline domain network. That, in turn, allows us to pick from a set of tiers. We'll pick cathodic protection, and which will then populate our subnetwork names. You could run this trace using a flag, but we're going to go ahead and pick CP Zone 2. And then we're going to click Run. You'll notice here the tool shows its progress. And once it's complete, types on our screen have been selected. I'm going to go ahead and close this window. We can see the extents of this traced CP subnetwork. We're going to go ahead and use Explorer to zoom in and review some of these attributes. As we can see at this point, we have a test point assembly connecting two different CP zones. There is an insulator here which stops the trace. If we go ahead and click on this insulator that's next to this valve and look at its attribution, we can see that our cathodic protection traceability is set to not traceable. That stops the trace between these two zones. If we click on our test point, we can see that this is the connection point between two different subnetworks. It also serves as a subnetwork controller, which we'll discuss in a little bit. As subnetworks are stored in the database, they can also be symbolized, allowing for a quick overview of the subnetwork extents without running a trace. This should match the trace data if the subnetworks have been recently updated. In our Contents tab, we're going to go down here to Pipeline Networks and expand that so we can see cathodic protection. You can see that our different CP zones here have symbology. We'll turn on this layer, and you can now see a highlight behind these pipes. Let's zoom out a bit so you can see that a little more clearly. We have one CP zone assigned here. You can see it highlighted in yellow, and the other one, which we just traced, is here highlighted in blue. Let's go ahead and make a change to our CP data that would require us to update the subnetworks. We're going to add a new test point and divide two CPAs with an insulator at a valve. We'll zoom in here to this valve. Next, we're going to add our features. On the Edit tab, we're going to click Create, which will open our Create Features window. And then to easily find the feature we want to add, we're going to type flange in our search window. We'll then pick the entry under Insulation Junction. At this point, we can add attribution before we place the feature. We can populate any attributes needed based on our as-built. For now, our main focus is we need to populate cathodic protection traceability with not traceable. This will ensure that our new CP zone stops at this feature. We'll go ahead and place this next to the valve. Next, we'll go back to our Create Features tab. And now we're going to add our test point. We'll type test in our search window. We're going to go ahead and pick a composite feature. In this case, a set of 3 features that we'll place together. We'll pick test point with lead lavender. And if we look at attribution, we have the option of populating all 3 features attributions before we place it. We're going to go ahead and first place our test point north of this valve. And then east of the valve, we have a couple options here to place our junction. We can either allow it to automatically snap to the pipe, as UN rules allow these points to be placed on pipes, or we can right-click, say Snap to Feature, and click Pick Edge. We can finish our sketch, and our new features are created. Before we go ahead and recreate our subnetwork, we're going to go ahead and add a test point reading. We'll first select our test point. We're going to open the attributes window. We're going to expand the related items. And we're going to pick CP test point reading. Note that as test points are an asset group under pipeline devices, there are some other related tables specific to the other asset group shown. We're going to go ahead and right-click, say Add New to Relationship. And we can populate all of these attributes using the test point reading information we received from the field. Next, let's go ahead and set this test point as a controller for our new subnetwork. On the Utility Network Data tab, we're going to click Modify Controller and select our new test point. First, we're going to set a terminal. In this case, we're going to set this to terminal 3. Next, we need to enter our subnetwork controller name. We're going to call this term 3. And for our new subnetwork name, we're going to call this term 3 demo. The edits have been noted as being completed. Next, we also need to set our wire as a connector from our controllable feature to our subnetwork along the pipe. Over here, we'll select terminal connections. We'll select our newly added test lead wire. Under test point, we'll set terminal to terminal 3 so that it aligns with our test point, and we'll click apply. Now that we've set that, it's time to regenerate our subnetwork. First, because we've made some edits, we need to ensure that all of our dirty areas have been validated and check for any possible errors we might have. We're going to validate it against our entire extent. Our validation was successful. Next, we're going to save our edits. Next, we're going to open our subnetwork tool. We'll go ahead and close these boxes as they're no longer needed. In our Geoprocessing Tools tab here, we're going to go ahead and type in Update Subnetwork into this window. You can see that's already been started. We're going to go ahead and pick our utility network, then our domain network. And under our tier, we're going to pick cathodic protection. You would use the same tool to update the other subnetworks. We found that this tool does take some time to run. We recommend that you schedule it to run off hours and on occasion so that the line work is frequently updated for your users. Like all geoprocessing tools, the tool also runs faster if you run it through a Python window. We're going to go ahead and click Run then. Our subnetworks have now been updated. If we zoom out, we can see that our pipes now have a different colored highlight on each side of our new test station. If we go ahead and look at these pipes, you can see that this information is also stored on the pipe itself. If we look here, our CP subnetwork name has our new Terminal 3 demo subnetwork. So the subnetwork fields can also be used to determine which pipes are unprotected for review for any of your steel pipes missing a subnetwork. You can go ahead and review them further, and that's also quite useful for your annual reporting when you need to report on unprotected pipe. This can also show where you may need to do some field validation to locate insulators and cathodic protection equipment to complete your cathodic protection networks. Please contact us if you would like to discuss implementing subnetworks in your system, or if you would like to discuss possible data remediation initiatives necessary to ensure your data will work with Esri's subnetworks.
UDC